Hello friends, welcome back to my channel. So today we are going to learn about error detection methods. Okay, so previously we have seen various kinds of error detection method, that is LRC, CRC, VRC and checksum. Okay, so that is longitudinal redundancy check, vertical redundancy check, cyclic redundancy check and finally checksum. These four methods are mainly used to detect the errors during transmission from one device to another device. Okay. Now we will see about the error correction methods, how those errors are going to be rectified and how those errors are corrected during transmission or retransmission of data. Right. So the first method is to correct the error is Hamming code. Okay. How these Hamming codes have been rectified and detect the errors. Let's see an example. Okay, so in our first example, we will transfer 7 bits of data. Assume that we are going to transmit 7 bits of data. As we know that computer can accept only a binary information. So this Hamming code uh, is function on second layer of OSI layer model, that is data link layer. Okay, so this 7 layer, that is this 7 bits, okay, is going to be transmitted from source machine to destination machine. How these 7 bits are transmitted and how these have been checked and correct the errors, we will see. Okay, so right. So assume that we have original bits, that is 7 bits of Hamming code. So we have a formula, that is 2 power r greater than m plus r plus 1. Okay, here r is nothing but the redundancy bit and m is nothing but the number of bits. Okay, so that is 7 bits, right? This m refers to 7 bits, that is the original data, and r refers to the redundancy bits. So here r I'm going to increase gradually one by one. Okay, initially r equal to 0. Okay, so why I'm going to increase the r value? Since we need to satisfy the condition, or we need to make the condition, okay, true, until we have to increase the r values from 0 to, and until we, the condition will be true. Okay, so initially what I'm going to do, I'm going to initialize r equal to 0. Okay, that is now here I'm implementing the formula, that is 2 power 0 greater than, here what is m is nothing but the 7 bits, 7 plus 0. 0 is what, r value. So initially r is 0 plus 1. Okay, so as we know that 2 power 0, 2 power 0 is nothing but 1, that is anything power 0 is 1 greater than 8. Okay, here our condition is false, so I'm going to increase the r value by 1. So now my r becomes 1, that is put r equal to 1. Okay, that is 2 power 1 greater than 7 plus 1 plus 1. 2 power 1 is 2 greater than 7 is our original bit. Okay, and r 7 is our original bit, our r value is now 1. So I have put here, I have mentioned here 1 plus 1, formula 1. Okay, so this becomes 9 and this becomes 2. 2 greater than 9, obviously it is false, so false. So next I'm going to increase the r value by 1, that is r equal to 2. 2 power 2 greater than 7 plus 2 plus 1. So 2 power 2 is 4 greater than 10. Obviously this condition also met false. Okay, now I'm going to increase the value of r equal to 3. 2 power 3 will become 2 to the 4, 4 to the 8. So 8 greater than 11. Obviously this condition met also false. Now I'm going to increase the value of r value of 4. So here 2 power 4, which becomes 16 greater than 7 plus 4 plus 1, which becomes 12. So 16 greater than 12, obviously it's true. So therefore, my R value is 4. Okay. So R value is 4. So we have to draw 11 boxes. How we are going to draw 11 boxes? So if my R value, uh, how to write the R values? So R equal to 4 means you can write as R1, R2, R4, R8. So 4 values. Okay. 4 values. Sorry. R8, 4 values. Okay. 4 values. Okay. Suppose if my value is R, so if we here, if my condition R will met at R equal to 5, if my condition met at R equal to 5, then my value will become R16. If my R value become 6, if my R value condition met at R equal to 6, then I can write my R values R32. Similarly, it goes on. Okay. So you have to square the value of R. Since my R equal to 4, I can write as R1, R2, R4, and R8. Okay. 4 values, only 4 values. So how to draw the number of boxes? So you have to draw the boxes based upon the R value and M value. So our M value is what? 7 bits. Now our R value is what? 4. So 7 plus 4, which is nothing but the 11 boxes. So 11 boxes you have to draw. Okay. 11 boxes you have to draw. So on the first boxes, so 1, 2, so how you can draw the values? Okay. So here first you have to write the from right hand side R1, 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 then second box is R2, third, fourth R4, 6, 7, 8. On the R8, 8 boxes you have to fill R8. So first value, that is R1 value, should be filled on first boxes, R2 value second boxes, R4 and R8. The remaining will be the original bit. So what is our original data? That is 1, 1, 0, 1, 0, 1, 1, right? So this is our original data. In this way you have to write. Now we have to find the what is the value of R1, R2, R4 and R8. Here you have to find the R1 value and fill the remaining boxes. Okay. So in this way you have to fill the boxes. We don't know the R8 value, R4 value, R2 value, R1 value. So to find R1 value, R2 value, then R4 value and R8 value. So you must find the R1, R2, R4, R8 values, right? Okay. So first, how to find the R1 values? So here I'm going to take the first value as R1. So 1 means odd number, 2 means even number. So here you have to select alternate boxes with number of ones. So you have to select alternative boxes with number of ones alone. Okay, which should be in odd or even number. Let's see how. First, I'm going to use R1 value. R1, R2. Okay, sorry, R1 first boxes 2, 3, 4, 5, 6. So alternative boxes I have chosen. Now I am going to count the number of ones alone. 1, 2, 3 and 4. So we have to count the number of count the number of ones on selected boxes. Okay, selected boxes. So we have selected here 1, 2, 3, and 4. 4 is what? Even number. So even means we have to make this as 0, right? Okay, right. So now we have to find the R2 values. Successfully we have find R1 values. Now we have to find the R2 values. Since here we have 2, okay, we have to select 2 boxes and left 2 boxes. Okay, then again you have to select 2 boxes, then again you have to left the 2 boxes, then alternatively you have to select another 2 boxes, right? Okay, so R2 elements, I have selected 2 boxes and left 2. Again I have selected 2 boxes and left the 2. Now I have to count the number of ones. 1, 2, 3, and 4. So what is our value? 4. 4 is what? Even number. So again my R2 value becomes 0. Okay. Now I have to find the R4 values. 4 means I have to select 4 boxes. 4 boxes select, 4 boxes left. Since there is no additional continuation of boxes, so I'm going to leave them alone. Leave it as it is. Okay. Now count the number of ones. 1, 2. Only 2 is there. 2 is what? Even number. Again my R4 values become 0. Now here R8. R8. R8 means we have to select 8 boxes. 1, 2, 3, 4. Since there is no additional boxes on there, so I'm going to leave it as it is. So now I'm going to count the number of boxes. 1, 2. Number of ones. 2. 2 is what? Even number. I have mentioned this 0. This is our original message for transmission. Okay, this 7 bits will change as the original message. Now this message is ready for transmission. Okay, so this is our original data. Okay, check 1 1 0 0 1 0 1 0 1 0 0, right? This is our original data. On the receiver side, again the whole word is going to be rechecked. Okay, so let's start with R1 values. R1, R2, R4, R8. So R1, R1 means what? So I have told you to select the alternative boxes. Okay, alternative box means one box select, one box left, one box select, one box left. Okay, so right. So initially I'm going to select the first boxes. First box I have selected and left the second boxes. Select. Now count the number of ones. One, sorry, from right hand side. 1, 2, 3, 4. 4 is what? Even number. So R1 value becomes 0. Okay. Now I'm going to check for R2 values. R2 values. Again I'm going to select 2 boxes, 2 left. 2 boxes selected, 2 left. Again 2 boxes selected. So I'm going to count the number of ones. 1, 2, 3, 4. R2 also becomes 0 since 4 is what? Even number. So I mentioned R2 also 0, right? Now I'm going to check for R4 values. Okay, so 1, 2. Again 4 boxes left. So since there is no additional boxes, I'm going to leave it as it is. Now I'm going to count the number of ones. 1, 2. So R4 also becomes 0, right? Now I'm going to check for R8 values. Since this also becomes 1 and 2, so therefore R8 also 0. So R8 0, R4 0, R2 0, R1 0. At the receiving set, my original data has been received successfully. Okay, with original form. Now assume that we will change the bit. We will change the bit and let's see how Hamming code is detected. Okay, so this is my original data which is ready for transmissions. Okay, on the receiving side I receive the same data in this form. Okay, that is the third bit alone I have changed. This is the original data, this is the received data. Okay, so let's see how error detection has been detected and show the exact bit location of on the receiver side, right? So here I have mentioned the original data uh, that is R1, R2, R4, and R8. Now, as I previously told you, select the alternative boxes. That is R1. So first box I have selected, second left, third, and count the number of ones alone. So here 1, 2, 3. So 3 is what? Odd number. So for odd, I have to choose as R1 equal to 1, which should become even number. Okay. So 1, 2, 3. So 3 is what? Odd number. So I have uh, to change the number into even. I have to mention as 1. That is R1 equal to 1, right? So next R2 value. So R2 means what? I have to select two boxes and left the two, and select two boxes and left the two, and again select the two boxes. Okay, here my R2 value is equal to 1. R2 value equal to 1. How? Count the number of ones. So here I don't have values. Here I have values 1, 2, 3. Okay, 3 is what? Odd number. Again, to change it to even, I have to mention R2 equal to 1, right? Then next R4 values. Here 4 boxes selected and 4 left, since I have the value is R4, that is redundancy bit 4. Now count the number of ones, 1 and 2. 1 and 2. 2 is what? Even number. So I have mentioned the R4 value equal to 0, right? The next is R8. R8, since I have only 4 boxes, I have selected 4 boxes. There is no additional boxes beyond the 1. Okay, so I have selected only 4 boxes. Now count the number of ones, 1, 2. So 2 is what? Even number. So it becomes R8 equal to 0, right? So my original data is 0, R8 0, R4 0, R2 1, R1 1, which is looking like a 0 0 1 1. So if you convert it into binary form, okay, so which is converted into binary form, so you have to mention 8421, that is 2 1, that is 2 plus 1 3, that is it shows the position of the error bit is 3, that is 1 2 3, third bit has been errored. So in this way we will detect the errors and correct the particular bits. Okay, thank you students, hope you are all understand. If you have any doubts, please comment on my YouTube channel or WhatsApp my number. Thank you.